Again, today we're going to have a look at how you find the intersection of two three-dimensional lines. So let's just have a bit of a recap. Remember, the definition of a line is you have some starting point, P naught, and then as for different parametrics, so different values of t, that sort of, defines all the points along the line. So that might be, t is equal to 1, t is equal to 2, etc. So it defines like all those different points as it goes along that line. And similarly with the other line, you'd have some, it's not going to be called P naught, but you'll have some other version of P naught there. And as T increases, it will sort of, go along the line as well. So what we're trying to find is we're trying to find a value where those two X, Y, Z, components are equal to each other. If we call them T is equal to 1, T is equal to 2, if we try to find a common T, it won't necessarily give us a solution because they're not necessarily going to cross with the same value of t. And so what we do is instead of calling it t, we'll just give it another parameter so that we can sort of keep track of where it's going. And so what we generally use is like s is equal to 1, s is equal to 2, etc. Because we don't need to know, we just need to know when x, y, z, when they're the same between the both. And they can have different, one can have a different s to the other one's t. It doesn't matter at what time that point is at the line. I'm using the word time very roughly here, but and so we're just looking for a common point at whatever value of s or t. And so what we do is we rewrite both equations. So I'll just write this down sort of thing. So if you're trying to find the intersection, firstly, write one of them, write one line in t parametric. Write the second one in s parametric. Okay, so you have one in S and one in T. And then what you want to do is you want to equate the components, X, Y, Z. So you're going to X, Y, Z. And then what you're going to try to do is solve the simultaneous equations to see what happens. Okay, so solve simultaneously. If you get a solution for those three, then that will be your intersecting point. Okay, so if you get a solution, that will be your intersecting point, and we'll have a look at an example of that. If you get no solution to those simultaneous equations, then those lines don't intersect. And there's a couple of reasons why they might not intersect, because they're sort of going off in different directions. They might be parallel to each other, etc., etc., etc. So that's the format of what we're going to do today. As per usual, it's probably easiest seen in an example. So let's go to an example and have a look at a particular one here. Okay, so let's see if the following two lines intersect. So x, just to take a one, x minus 13 over 3 equals y minus 4 over 2 equals z plus 7 over negative 2. So that's my first line. And my second line, I'll just write over here. I should give myself a bit of a space. I'm always sort of crushing myself up a little bit where I don't have to anymore. Y is equal to 8 minus 2t, and z is equal to 14 minus 3t. So let's have a look at these. Okay. So firstly, our second line here, that's already in a parametric in terms of t. So I'm just going to leave that one as it is. It's already sort of nicely done. But with this this first equation here, I'm gonna rewrite that as parametric. But instead of using t, I'm going to use s as my parameter. And so, like I said before, we can sort of compare them. So let me now write x in terms of s. And so we have x is equal to 3s plus 13. We have y is equal to times by 2, 2s plus 4. And z is equal to negative 2s. Gee, that looks like negative z up there, but it's not. It's just z plus 7, so that'll be minus 7 there. Okay, so we now have our two equations. So two lots of parameter equations. Okay, and so now what we're going to do is we want the same x, y, and z values in here. So that's what we sort of need to solve for now. Okay, so here we go. So we've got 3s plus 13. We want that to be equal to t minus 1. That's the x values for each. 2s plus 4, we want that to be equal to 8 minus 2t. and negative 2s minus 7. We want that to be equal to 14 minus 3t. Right, so let's have a look at how we might go about solving simultaneous equations here. What I might do is, it looks like for this one here, that one might be easy for me to figure out what t is equal to. So I might do that, and then I might substitute it into probably the second equation, and then check to see whether it works with the third. Okay, so if I rearrange here, t is equal to 3s plus 13 plus 1. So that's 3s plus 14. So that's my value of t there. I'll now substitute it into the second equation. So I've got 2s plus 4 equals 8 minus 2t, and t is 3s plus 14. And I'm going to have to crush this up a little bit. I haven't left myself much space as per usual. So I've got 2s plus 4 is equal to, I'll try to do this all in one go. And so I'm going to have negative 6s, and I'm going to have 8 minus 28. So that would be negative 20. I'll just double check that I got that right. 8 take away 28, and so that'll be negative 20. Yep, that's right. And so here, that's going to give me, it's going to be 8s is equal to negative 4, so it'll be negative 24. And so that gives me s equals negative 3. That came out nice. Just double check that. 2s plus 6s, that's 8s, take away 4, negative 24 divided by 3. S is equal to negative 3. So what I'm going to do now is just come back up to here and substitute that value of s back into that value of t there. So t is equal to 3 times negative 3 plus 14. That's equal to negative 9 plus 14, which is 5. So I've got t equal 5 and s is equal to 3. So they're my values for t and s. Now, I need to check it in the third equation to see if it works. So if this doesn't work in the third equation, it means there's no solution. And so it means the two lines do not intersect. If it does work in there, it means there is a solution when t is equal to 5 and s is equal to negative 3. And we're good to go. All right, so let's just double check this. So check that negative 2 times s, what was s? Negative 3 minus 7 equals 14 minus 3. T was 5. Negative 2 times negative 3 is positive 6. Take away 7 is negative 1. And 14 take away 15 is negative 1. So therefore we have a solution. So all three equations work for those values of s and t. So we have a solution. The lines do intersect. And so now we just need to figure out what the intersecting point is. Okay. So therefore, I'll put in blue. Intersect when s equals negative 3. T is equal to 5, and we'll just put it back into either one of the equations. Remember, with simultaneous equations, you can just put back into those equations. And so we're going to get x is equal to, what should I use? I'll use t is equal to 5. I think that's easier than negative numbers. T is equal to 5, so I'm going to just read off of this parametric up here. X equals t minus 1, so x equals 4. Y is equal to 8 take away 10, so that'll be negative 2. And z is equal to 14 take away 15, so that's going to be negative 1. Just let me double check that. 4, 8 take away 10, negative 2. And I don't know why I just wrote negative 1. I should have written z equals 14 take away 15, negative 1. So my intersecting point is 4, negative 2, negative 1. Hope that makes sense. Again, if we didn't get a solution, if this didn't check out here, then we would just say the lines do not intersect. And that would be all you need to do. Thanks very much. See you in the next video.